It's about 4 a.m. right now. I don't know what you usually do at 4 a.m., but I feel like building a reality simulator right now, so that's what we're gonna do. You know, it's not gonna be too complex. It's gonna be simple for now. Let's talk about some of the science first. Shoot, I wish I had some nerd glasses to put on for this. I think I only have my sunglasses, but that's fine. I guess I'll just have to settle for being the coolest professor in the room. Okay, let's talk about some science. As far as I'm aware, there are 4 fundamental forces in the universe. We have gravity, electromagnetic, and the strong and weak nuclear forces, fundamental forces of nature. Electromagnetism, weak interaction, strong interaction, gravitation. So what we're gonna do is we're just gonna create a simulation with these fundamental forces and see what happens. We'll start very simple. We'll get more complex. I think we're just gonna start with protons, electrons, and then neutrons. These guys will have the nuclear forces as well as gravity. They'll all have gravity. And then these guys will interact through electromagnetism with other protons and electrons. We're not gonna worry about any sort of quantum physics woo-woo. We're gonna keep it stupid simple. Let's get a new Unity project going. Yeah, it's early. Probably sleeping like a baby right now. Speaking of babies, little known fact, my mother, when she was nursing me, she did not feed me breast milk. Now that's for weaklings. She fed me C++, raw C++. She wanted me to compile big and strong. And now look at me. I have an IQ of 300 and a master's degree in telling the truth. Oh, by the way, the goal with this too is to start in 2 dimensions, and then we're gonna move to 3 dimensions. And I think it would be interesting if we get something cool going to port it to VR and see what we can do with this project after that. I don't have a PhD in physics though, so I'm actually not too familiar with the nuclear forces. So we're gonna start simple and just do electromagnetic force. And according to ChatGPT, the weak nuclear force can probably just be ignored unless we're including radioactive decay processes. This is gonna be our proton. This is gonna be our electron. So what we're gonna do is we're not gonna use the actual size and mass values for the particles because they're very small numbers. Maybe we'll just have, say, the mass of an electron as 1, and that's our standard, and then we'll scale up from there. So what we're gonna look up first of all, mass of electron, and then mass of proton. Break the calculator out. Divided by electron's mass, 1,836. So the electron's mass is going to be 1. Proton's mass is going to be, we'll just round this off to 186.23. So the mass of an electron is 1, or the proton, 1836.23. And we'll change these guys' gravity scale to 0 because we're adding our own gravity. You know, let's do a neutron too. Mass of neutron, 1,837.74. Just make the proton some kind of red like that. Electron blue, neutrons like orangish, like in all the science diagrams. Radius of proton. The proton radius puzzle? An unanswered problem in physics relating to the size of the proton? Oh boy, I have a lot to learn about physics. Okay, it looks like for some reason this classical electron radius is bigger than the proton radius that's accepted. So the classical electron radius is theoretical construct. I think we're just going to go with scaling them based on their mass. If we make this 1836.23, I mean, that's just massive. This is the real scale of the universe, friends. Except it's not. It's actually much smaller. It's much more different than this. So we're just gonna go with something reasonable, honestly. We'll just do like 1.6. So it'll be bigger, but not too much bigger. Because we actually need to be able to see these things move around. It almost looks like it's turning into a Google logo. I want a script for myself to be able to control these. How about we just call it God? Because I'm going to be the god of this universe. Static class, because you can't have more than one god. Not in my universe. My universe is monotheistic. Okay, so for electromagnetic force, here's how we calculate the force with the Coulomb constant and the charges of the 2 particles divided by the radius squared. Well, since I'm god of this universe, I don't really see any reason why we have to keep these constants the way they are. Why don't I just make my own constants? I think this is going to make it interesting where we can actually play with the different constant values and see how they change things. Okay, let's see if this works. It probably won't. Nothing works first try. Ooh. So we got 1, boom. Okay, no errors. Oh, they're moving. There we go. Okay, let's try a proton. Nothing with the proton. Hold up. There we go. Ooh. I don't think they're moving. Well, these guys are doing something. Oh, looks like the protons are moving away. Maybe. Okay, so they're moving. Maybe we just need to increase the charge. Okay, so those guys are moving away, but the electrons are also, oh, look at that, we can trap it. Okay, but it should be moving towards them. Okay, we need to fix that. Okay, we're gonna have to debug.log a few things. Oh, I know what the problem is. We need to use the math abs on it. So if we do that, boom, boom, let's go. More of these guys. Okay, now it's really starting to get laggy. Okay, these guys don't have any interactions though, so let's go ahead and add gravity. Gravity. I'm wondering if maybe we should have just done like an abstract class of a particle. It just inherits the different or charge. I don't know. I don't care to do that right now. We're just gonna keep things simple, stupid. Void apply gravitational force. Here's 1, 2. Billiard balls. Why'd they disappear? You're not supposed to create or destroy energy. Okay, hold on. What's going on? They're just flying away. I don't know why that's happening. But now we have different kinds of interactions we can play with. Oh yeah, look at that. Now things are starting to get interesting. Oh, look at that. They're orbiting each other. I want to set up kind of a box. We don't want our universe to be infinite. And what I'm going to do, I'll just show you. Let's pull up paint. This is the Big Bang. We're literally making the Big Bang right now. Here's the center. When a particle flies out beyond this universe, what it's going to do is it's going to go past it and then detect it and teleport it on the other side. And so that way it's always constrained within the bounds of this circle. And any particles that want to fly out wrap back around the other side. Like it's a big 100th dimensional toroid or whatever it is. And if you've ever seen like different theories of how the universe is infinite, I wonder if this is maybe exact star this video about some college student making a simulation and it was the entire universe. This is how it makes the most sense in my opinion for this program, so I wouldn't be surprised if the actual creator of our universal simulation did it in this way as well. Before we game object particle in particles, particle adjustment deposition. IntelliSense is just writing all my code. I barely have to touch the keys. We want gizmos to be able to see the actual universe. So let's add that down here. On draw gizmos. What's the function for this? Is it draw wire sphere? Oh, I just want to draw a circle. Ask ChatGPT. Oh, that's interesting. And then I can just copy this gizmos code. Yeah, guys, AI is going to replace us in the future, but for now, it's just a good tool. If you're against using AI as a tool, if you're completely opposed to it, this isn't the channel for you. Because here we embrace the future. Okay, we don't want it to be yellow, though. I don't know why I chose that color. Yellow's disgusting. Do you see that? Look at this guy. He's going to the edge of the universe, and he's appearing right there. Boom. Okay, let's add some more. Let's have some fun. Find some. Whoa! I want these guys to like conglomerate into some planets. What I want is to make some galaxies here. Look at this. They're going so fast that they're just blinking. This is pretty cool, but we got some more stuff to add to it. I think maybe if we add the strong nuclear force, we can get some more conglomerate behavior, some more cohesiveness. So the strong nuclear force is quite a bit more complex than just electromagnetism and gravity. So we're going to simplify it a bit. So if we have two particles that are like nucleons, like protons and neutrons, over short distances, where this distance is very small, the force is very strong, and it pulls them together until they're very close. And then when the particles do get closer together, the force actually becomes repulsive, and it pushes them away so that they don't get too close to each other and become a single point. And another thing to note is that with things like gravity, they are proportional to the distance squared. So as they get closer to each other, the force increases exponentially. Whereas with the strong force, it's actually just proportional to the distance. Kind of, but it's a little bit more linear. So as they get closer to each other, the force doesn't change as rapidly, but it's very strong at close distances and even a little repulsive when they get too close. At further distances, it disappears pretty quickly. So that's how we're going to do that. So back in our simulation, what we're going to do is we're going to go back into the code and we're going to add some new constants. So let's add a strong force constant, and we do want it to be a lot stronger than gravity and the electromagnetic force. So let's set this to just 50 for now. And what we also want to do is define ranges where the force is attractive and repulsive. And since it gets so weak after short distances, we're going to have a range where this is our attractive zone, and then a shorter range inside of that where it's our repulsive zone if particles get too close. So if a particle is out here, there's no attraction. If a particle's in here, it gets attracted. And if it's in here, way too close, it gets repelled. So let's define those constants as well. And let's set those to something small. So let's set the attractive to maybe just 3 for now. And then let's set the repulsive to, let's just say 0.1. And we might tweak these values later. And also I think what we're going to do is take these force functions and move them into the God script. And now we're going to have to change some things. Okay, that should be fixed. Things are looking good. Oh, you know what? I actually think I made a mistake on the universal radius function. We're just flipping its x and y position, but that's not actually going to work. We need to actually put it back in the circle. And for that, we're going to have to do some trigonometry. I could do that myself, but that's a task that ChatGPT could do easily enough, so I'm just going to copy this function. Oh, okay, so ChatGPT actually did it in a simpler way than I was thinking without any trigonometry. So we're going to paste that code in. So what it did is it just got a vector direction to the particle and then flipped that vector to go in the opposite direction while multiplying it by the universal radius, and then that gives us the new position. And that's actually a smarter idea, so I just learned something new. So now let's test that out, and let's spawn some stuff in. Now things are acting more naturally and smoothly, except when I spawn a lot of particles, of course, where my laptop is starting to lag. So now I'm going to go back to ChatGPT and ask if there's a better way to manage all of these particles to make it less laggy. Okay, so ChatGPT suggested a few ways to do it, including one way which I thought it would suggest using a particle system. So what we're going to do is add a particle system to God. And there were a few other ways that it suggested, but for now, this is what we're going to try. Okay, so it's kind of outlined here how we could use the particle system in order to implement the same forces, but using Unity's built-in particle system. What we're essentially going to do, if you recall back from 9th grade physics class, Newton's second law, F equals ma, we can't directly apply forces to particles in Unity. So what we need to do is just modify their velocity directly. And in order to figure that out, we can just solve for acceleration, which is the force divided by the mass. And then since acceleration is also equal to the change in velocity over the change in time, and our change in velocity equals our acceleration times our change in time. And this change in time we can get from Unity's time dot delta time. And that'll tell us how much time has passed since the last frame. So every frame, we can calculate our acceleration and then multiply it by time.delta time to get our change in velocity. And like I mentioned before, I could go ahead and program all of these changes that it's suggesting manually. We could program all of that manually in here, but to save time, we might as well just allow ChatGPT to do it, as long as we're specific enough with what we want it to do. So we'll just go ahead and ask it. Okay, let's go ahead and implement this. I put a particle system on a game object, so let's go ahead and create a new God script. And then what we're gonna do is we need to be able to spawn 3 kinds of particles, the protons, electrons, and neutrons. We want them to be set to respective hexadecimal colors that I set. We need the particle system to emit one of those particles. Depending on which mouse button I click, one gets emitted. So let's go ahead and do that. Okay, so now it's generated a new God script for us. So if we're just taking a look at this, so it's got electron color, set them to cyan, red, and gray. So left click still does an electron, right click still does a proton, middle click is still a neutron. And it calls this function emit particle. To get some mouse positions, this is 0, perfect. So it's emitting a particle with the emit params. Okay, so it's only setting the start size to 0.1, so we'll need to change that. So this script isn't actually doing exactly what we want it to do. It's adding a pull towards the center of the entire universe. So we'll implement it anyways, just to see how it performs, and then we'll come back here and tell it to fix it to get the exact behavior that we want. So we're going to comment all of this out, and then put in the new script. Okay, let's see what this does. So there's our little electrons, there's some protons, there's some neutrons. So it's kind of working, and they are dying fast. Okay, so what we want to do is set the particle lifetime to be longer than it currently is. And then we also want to set our own colors for it. And we also want to set custom variables for the sizes and masses of all these, and we don't want them to be pulled towards the center. We just want them to experience attractions toward each other. So let's go ahead and go here. Let's re-upload. Okay, let's modify it with a few things. First of all, I need some tunable variables to be able to set the size as well as the mass of the different particles. So I need to get rid of the pull towards the center of the universe. I don't want that at all. All I want is for it to loop over all the particles and then apply the different forces. Okay, so it's updating it. It gets its acceleration as the net force divided by the particle mass is perfect. And then the velocity gets incremented by the acceleration times time.delta time. Although I wonder if this time.delta time should be fixed delta time because we're doing it in fixed update. I wonder why it set the proton size as greater than the neutron size. Aren't neutrons greater than protons? Maybe I should just double check that. Nearly equal in size. Okay, I'm not sure why it made this bigger than the neutron, but we'll fix that too. Okay, so everything's just attracting each other. It's like the electrostatic force isn't actually working right now. Okay, so I think I figured out the problem. Well, first of all, our Coulomb constant just wasn't big enough. And second of all, the sign just needs to be reversed. Just one minus sign. Freaking minus signs, always messing us up. Okay, let's try this again. These guys repel, perfect. These guys, oh, they're not repelling. This is strange. Okay, well, things are kind of working, but it is still very laggy, very fast. In fact, I think it's even laggier than our first solution. Okay, that's a problem. Okay, so Chatty is also suggesting we could use compute shaders. Apparently, this allows us to use the GPU for parallel processing. I've never used these, so I have no clue how to, but we could give it a shot. We'll create shader, compute shader. Okay, so it's given us something to put in the particle compute shader. Well, let's put this in. It's almost like a different programming language here, but there are plenty of terms I don't recognize. So it looks like we're starting to get into multi-threaded programming right now. So it's also defined these compute buffers that I'm not sure what they are yet. We gotta learn what that is. Let's see what else it did. It also took out our colors. What the heck? Oh well, we'll fix that. And it is also not doing any of the force calculations. So it looks like, if I'm understanding this right, so this compute shader, I guess, is telling the GPU how to do the force calculations itself. And this script is essentially kind of outsourcing to the GPU what it needs to do using something called a buffer, a compute buffer. If I'm understanding right. It might totally break. Maybe nothing will happen. We already got an error. Oh, we're getting lots of errors. Well, we have some action. Okay. First of all, we gotta fix these errors. I don't want multi-threading errors blowing up my CPU and GPU. Okay, looks like we need this line to fix that threading error. By the way, what the heck is a float 3? Is it kind of like a tuple? Stores 3 values, 3 floats in there? Okay, everything should be good now. Should be. It almost reminds me a little bit of Agario, if any of you remember playing that in 7th grade. Okay, I think our Coulomb constant still needs to be higher. Let's try 100,000. That should do something, right? Are you kidding me? Oh, you know what? I think the compute shader is still using these values. I think what we need to do is just modify the God scripts to actually have these values be representative of the values that we define in the code, actually, rather than just being set. We're still gonna keep that at 100,000 to see what it does. Boom. Boom. Okay. Not bad, actually. Oh my goodness, they're all transparent. I'm not sure why. Okay, that should fix it. Okay, look at that. Playing ping pong. Let's add some protons. Let's add some neutrons. Yeah, these guys are just kind of staying in the center for the most part, which makes sense. Okay, but look at that. The simulation's faster. It's so much faster. I have a small NVIDIA GPU in my laptop, and it is kicking. Let's add some more of the little boys. More! More! I feel like Kylo Ren. How many particles can we support? Now that's chaos. Perfect, perfect. This is kind of like plasma, though. If you want to know what plasma looks like, it probably looks something like this. Kind of like a soup. Just a soup of particles. Okay, but the electrons are actually going so fast that they're going outside of the bounds. Okay, that's not... They're going way too fast. Okay, but that's what we got right now. Okay, let's go ahead and add the strong force, finally. So it's added our strong force constant and inner and outer radius to the compute shader. It's got some bools for whether it's a proton or a neutron. So here it's checking which radius it's inside, and either flipping the force if it's inside the radius for repulsion, if it's inside the outer radius for attraction. Okay, and the updated God script. Alright, let's try it. I'm actually kind of excited to see what this does. Oh dear. I wonder if the force from the strong force is just flinging them when they get too close. I think it's just flinging them away. Okay, let's just see what happens when we add 1 neutron and 2 neutrons. Okay, let's add 1 more. What? What? Why did it just... Why are they teleporting? Okay, this is odd. This is bizarre. Where did the other ones go? Oh. They're on different Z points still. Let's just set all of their Z positions to 0 here. 1 neutron, 2 neutron, and... I think our radius is too short, because these guys only have a size of 3. Let's make it a little bigger. How about 10? I don't know, that might be too big. And 1, and 2. Are you moving? I don't think they're moving. Okay, I'm assuming we can't do a debug.log here. Yeah, I guess not. Okay, you know what? Looking a little bit at the code that it gave me, this part smells a little bit fishy. I'm not really sure why it did it this way. I think it kind of messed up. I think we can take these out. Let's just say if current charge is greater than or equal to 0, and other charge is also greater than or equal to 0. That just seems like it's what should have been done in the first place. Okay, 1 neutron. Another... Oh, there we go. Whoa. Okay, that's better. Much better. Yeah. What happens if we just do 2 protons? Come on. Form atoms. Form atoms. It's not doing it. Enough. Okay, I wonder what will happen. We can just change these parameters on the fly. What happens if we increase the strong force outer radius? Oh, look at that. Oh, look, it's taming itself a little bit. Let's set everything to 0. Let's just have a few neutrons and a few protons. Okay, let's try just increasing the strong force a little bit. Okay, this is kind of like what we want, but in a bit of slow motion. Okay, I think it needs to be stronger. Okay, this is kind of what we're looking for. Yeah, that guy just got ejected. You know what, that kind of reminds me of like, I don't know, radioactive decay, where it just ejected a proton. Yeah, we're kind of simulating nuclear physics here. It's kind of fluctuating a little bit too much. I don't really want it to be fluctuating. I kind of want it to be a little bit more stable. I want to make it so that they kind of tend to clump together and stay clumped together, rather than flying toward each other and gaining tons of momentum and then flinging apart. Okay, so I think what I'm going to do first is I'm just going to try adding drag. It's not completely realistic, but it might do something interesting, I don't know. So basically the velocity will be multiplied by a number less than 1 based on this drag coefficient. Oh, look at that. Now it's kind of staying together. Check that out. Let's increase it even more. Up to... It's over 9,000! Okay, that's kind of interesting. Yeah, we're going to leave it at over 9,000. So now the strong force is kind of keeping it together, whilst also keeping it a little bit apart, and the drag seems to be taming it down a little bit. Okay, I see you. Now what happens if we add some of the repulsion with the protons back in? Let's see. Okay, oh, it's getting a little unstable, just a little bit. I think we need to make the coulombs greater, and the strong force even greater than that, so that the electrons can actually have kind of a chance to orbit around here. And let's add a little bit of, whoa, bit of gravity. Just a tiny bit, Okay, now let's increase the strong force. Increase it. Maybe too much. These guys, I don't know what they're doing. I wonder if we just need to tune the parameters better. Let's just make a really big nucleus and see what it does. Okay, that's not allowed. Yeah, all of these protons orbiting each other like that, that should not be allowed. We need to increase it more. We do kind of have some clusters of atoms running around, which is exciting. Yep, look at them go. More complexities emerging. It almost looks like one of those circles that people use as displays to kind of, whoa, to kind of display the volume of the music. Like you could play some rap over this. I did figure out if you add lots of protons to this, it does kind of make it a little unstable and chaotic, but I want to see how many you have to add before it becomes completely unstable and doesn't even stay together. Because if it just stays together forever, that's bad. We only need it to be doing this when there's tons of neutrons to keep together. Okay, you know what? I don't think this approximation for the strong force is actually going to cut it for us, because it is still dominating even when a couple of protons are right next to each other. Because at short distances, since this is only proportional to the distance instead of the distance squared like the other ones, this is going to be weaker because it decays faster by being divided by the distance squared than just the distance. So what this is suggesting here is actually to use this Yukawa potential, where we put the r squared in the bottom and we introduce an e to the negative r over another r, which is a range of the strong force, rather than having a hard cutoff at an outer radius. So I'm going to try that instead and update this compute shader. Okay, that shouldn't be happening. Yeah, I don't think that's working too well. It's kind of off. Yeah, it's a little off. I wonder if maybe we tried just the distance cubed. They're still clumping up. Yeah, that's not what we want. So if we turn the Coulomb constant up, is it kind of working? Yes, maybe? It is kind of self-forming into these stable shapes. Okay, but it's still a bit slow. I do still want it to be a little more chaotic. We just turn this strong force up even more. That's 264,000. Ooh, I wonder if we put it at 500,000. Again, oh, not 5 million, but 500,000 kind of works. This is 4 protons and 4 neutrons. Let's add an extra proton. We want this shape to destabilize. So let's turn up the Coulomb constant as well until it does. It's a little bit unstable. Let's try 200,000. Okay, 300. Okay, there he goes. I kind of want it faster, though. It's still a little bit slow for my tastes. 600,000. Let's try that. That might be a little bit too unstable. Okay, but we did kind of find a good ratio where the Coulomb constant is about 2/3 the strong force constant. Yeah, that might work. I wonder why all these guys are blinking like a bunch of Christmas lights. Okay, we're starting to get atoms. So if we add a little bit of gravity back in, how much should we do? 100? Oh. Oh, okay. Why was 100 being so chaotic? Gravity isn't even that big, but it's big enough to prevent them from doing anything useful. But if we just do 10, that seems to be pretty good. Looks like we've got kind of a delicate balance going, which is nice. We're starting to get some molecules forming. I don't even know, like, is this type of molecule even possible? 2 neutrons sticking together? I'm not even sure. What happens when we add a bunch of more electrons around here? You can kind of see that, right? The electrons are actually kind of like zipping around and orbiting them a little bit, being exchanged all over the place like a soup. And I wonder if instead of drag, we can make it a little more interesting by adding energy loss through radiation by emitting photons. So in real life, photons can be emitted from particles in a bunch of different ways. From what I've seen, 2 of the ways are from particles accelerating and decelerating. Let's say a proton's moving in this direction, and instead of having another force of drag, instead, what we're going to have it do is when a particle accelerates in one direction, it's going to emit a photon in some random direction, and that's going to decrease the velocity of this particle, and the energy that it loses by decreasing its velocity will be transferred into the photon, and that'll effectively have the same effect as drag. And what this photon can do is it can go hit, say, another particle like an electron and give it energy and accelerate it too. So we're going to have a chain reaction of particles accelerating and decelerating and emitting photons and transferring energy that way, instead of just having drag. And of course, this is all still major simplification, but we're going to do it anyways because this wasn't supposed to be a super accurate, true to reality simulation anyways. So the way I'm going to implement photons here is, let's have a proton again. It's accelerating. When we have drag, what we did is we just say, okay, its velocity turns into 90% of its velocity. So that energy is just lost. It's gone. What we're going to do instead now, that energy is going to be transferred into the photon. And how we're going to calculate that? We're just going to use the simple kinetic energy equation equals 1/2 mv squared. So we know that the energy that this particle is losing represents 10% of its velocity. Plugging that in to 1/2 of the mass of the proton times 10% of its velocity squared. And that's the energy that's going to be transferred into the photon. And we're not going to have the photon travel at the speed of light because that's just going to be way too fast for us to see. We're just going to have it at a reasonable speed, but it'll be the same speed to represent the fact that photons always travel at the speed of light. But behind the scenes, they're going to have a variable that represents this energy, so that when they hit another particle, they will transfer the same amount of energy, which will convert into more velocity in that other particle. Okay, so we've given these requirements to ChatGPT 01. Regular 4.0 was kind of having a hard time with it, so it's added this new emit photon function. And then it emits a photon with the energy lost. Okay, parts of this I'm not sure about. I'm not sure why it put in this line about initial kinetic energy. It's not even used. Let's see what it has to say about that. Yeah, I realized that I actually forgot to tell it to add a variable so that a photon is only spawned if a particle accelerates by a certain amount. This might actually crash the program. I'm not sure, but that might be kind of fun, so let's try it. Neutron. Neutron. Oh. Actually, you know what? We're just gonna get rid of all of this and start over. I think I gave it a little too much to chew. You gotta start simple. You would think that just a bunch of neutrons would be stable, wouldn't you? Apparently not. Maybe that's kind of like how it isn't in real life, for some reason. Probably not for the same reason. Okay, let's go back to our code, and we gotta take this one step at a time instead. Okay, so what we're gonna do for now to simplify it is we're just gonna have it modify the script to spawn a particle when the increase in velocity from another particle is above a certain threshold. It's just gonna send it off at the speed of light that we define. Okay, let's see what that does. These are not acting normally. Okay, for some reason, these guys are not repelling each other? Okay, this is odd. This is the main downside, in my opinion, about programming with AI, is that you don't fully understand the changes that it's doing, so if something messes up, you're never 100% sure how to fix it. Actually, you're usually 0% sure how to fix it. Yeah, if ChatGPT gives you broken code, don't try to debug it yourself. Just have it try to debug it and fix its own code. Oftentimes it will fix it, and it's a lot faster than just trying to fix it yourself, but if it doesn't, then you're just kind of stuck and you have to go fix it yourself anyways from scratch. Well, I give this alternative solution of just using this start function. We can try with that first, and if this doesn't work, then we'll just have to try the other solution or make it try again or give up. And errors everywhere. Oh gosh, I hate when it does this. It says rest of the code remains unchanged. You think I want to copy it all separately and put it in the code separately? Just give me the whole thing. Okay, that's the updated scripts now. Let's try that. Hopefully this works. And it doesn't. But remember, we don't go to try to fix it ourselves. Just throw the garbage output back in its face and hope that it fixes it. I'm getting this error. Think hard, man. Okay, gave us another God script. Let's use that. Hope for the best. Okay, no errors. Let's try spawning some things. Still doesn't work. It thinks it's an issue with how the particle mass and charge and type arrays are synchronized. I don't know about that, but whatever. Another God script. Let's try this one now. Hope nothing blows up. Boom, boom, boom. Oh, index out of range exception. Nice. Those are always fun. Yeah. Okay, I think it's finally working. After the 50th try. Spawning any photons? Maybe we just need to make their size bigger? I'm not seeing anything. I don't know about you. I could be yellow colorblind. Okay, gave us a new God script. Please work. Oh. It already has errors in it. Yep, still not seeing any photons here. We're gonna do an experiment. Let's just have it emit an electron instead of a photon to see if that does anything. If it actually emits the electron, then the real problem is with the emit photon method. Okay, it looks like it's not actually spawning any electrons either. Fidget spinner. Oh, there we go. Oh, okay. Looks like it finally fixed something. Interesting. Look at that. It's salting the Earth. Okay, looks like the photons are also having drag applied to them too, though, which we don't want. We want them to just continue. I suspect when we get access to more AI agents that can go in and test these things for us and automatically update the code based on the issues that they see on their own, they'll probably do better programming. Because let's be honest, if I were programming this from scratch all on my own, I'd still make a bunch of mistakes before I got it right. Well, first of all, the GPU's handling all these particles fantastically. Look how many these are. And they're still being spawned. What is going on? I think it might be affecting the gravity of these atoms weird. I don't know, but it's good to know that it can handle lots of these. Holy cow. Okay, that is weird. The lower I set the threshold for the velocity that needs to be changed in order for the photons to spawn, the odder these guys behave. They just behave so weird. I have a sneaking suspicion why it's happening. The lower the threshold is for when photons are supposed to spawn, the lower this threshold is, actually maybe not. Okay, looks like we got lots of them zipping around now. Let's add some electrons into the... Oh. Okay, what is going on? This is strange. Okay, I think I finally got it working. Yeah, it just took some more testing and being more explicit with O1 what the actual problem was. Okay, now we got all our little photons zipping around. Everything should be behaving pretty normally. Well, now what I want to do first is I want to create a script for our camera so that I don't just have to view the simulation from the editor view. I want to be able to scroll around from the game view. That's what we're going to have it do next. Okay, so it's made us a script called camera controller. Put it in there. I also want to try giving the particles trail renderers. I think that might look cool, especially for the photons. Well, they have pink trails, which means the materials aren't quite working properly. Okay, well this is interesting. And I don't know if the trails are disappearing properly. Looks like a bunch of cosmic rays. If that's what cosmic rays look like, I don't know. I imagine they look pretty magical. That just looks like a bunch of slugs. Oh, that's looking cool though. Oh, I know why the trails are lasting so long. It's because we set the lifetime of the particles to be basically forever, and then we set this to 1. And this isn't just 1 second, it's relative to the lifetime of the particle. Yeah, let's just set it to a really small number. Millionth? 1 billionth? Is 1e negative 45 the smallest we can go? I guess we'll try that. Okay, for some reason, using a curve for the trail lifetime size seems to work, but using just a constant number doesn't, even if it's a very small value. So right now we're getting these flashing lines, which I think are from the particles being teleported to the other side, and then the trail is following them. The only thing is though, after a little while it seems like the trails just disappear. They just stop for some reason. I'm not sure why. First, I think I'm gonna do just a debug log of the actual lifetime that we're setting the trails at. It looks like the trails are still being rendered in the editor view, or at least they're kind of detected there. They're just not being shown for some reason. Okay, I think maybe just setting the particle lifetime to the max float value is a bit excessive. So I'm just replacing this with my own variable particle lifetime, and then I just give it enough seconds in its lifetime to last an hour. Yeah, I think that's working better, but we still got these flashing lines from the particles teleporting. So I wonder if when we teleport the particles, we can just temporarily turn off the trail renderer and then teleport them and turn it back on again. I think this should work. So I turned it off here before we update the positions of the particles, and then in update, after it should have rendered a frame, then we can turn it back on if it's already off. Let's see if it works. And it doesn't work still. Maybe we need to wait for longer? I'm kind of second guessing whether we should actually have trails at all. Maybe it's not worth it. Okay, so instead of turning off the trails module, what I'm trying now is instead when a particle gets to the edge of the universal radius, I'll just set its remaining lifetime to 0, so basically delete it, and then spawn a new particle at the opposite end with the same velocity. And looks like the new photons are just getting deleted. Okay, for some reason the photons are now interacting with the nucleons. Okay, that's not right. Okay, I finally got it working. Now it's finally taking particles that leave the boundary, deleting them, and spawning brand new ones on the opposite side so that we don't get any of those streaks across the entire universe. That took a lot of manual refactoring to the code, but you know those times when you screwed up, so you have to go make a ton of changes to the code all at once and you're just crossing your fingers that it all works? Yeah, that was me just now, but of course I wasn't worried at all because I'm such a god at programming. There is another thing though. I think sometimes when atoms split, I think they're moving faster than the speed of light, which isn't allowed. So let's go back here where the velocities are updating. It'll be the same velocity dot normalized times speed of light. Yeah, that's looking a bit better. They're not just flinging everywhere. Well, this is looking pretty cool. I think the trail renderers were definitely worth the extra work. Oh yeah, that looks way cool. Okay, now what I want to do is make it possible for particles to absorb photons and gain energy from them. Okay, so I think what I'm going to start out doing is just checking for photon collisions and just deleting the photon if it gets too close to a subatomic particle. So here this one's about to collide and it should disappear. There we go. Looking pretty good so far. Okay, so now what I'm doing is I'm only applying drag if a certain particle has its velocity increased past the photon emission threshold. Here we're calculating the energy lost with our kinetic energy equation, and then we're giving that energy into our emit photon function, so that here in emit photon, it uses that energy to calculate a hue value for the color of the photon as if it were an HSV color. So that's going to change the photon's color based on how much energy it has. Okay, so we're getting colored photons, but now all my particles are just being deleted upon spawning in. Oh, I think I know why. It's probably this single equal sign. That'll probably fix the entire thing. And boom. Okay, that's weird. That is not normal. Actually, I think maybe we just need to decrease the photon emission threshold, but it's still a little bit too soupy. Actually, I wonder maybe we could just apply the drag separately and then only emit a photon if a nucleon tries to go past the speed of light. So instead of computing the velocity change and then seeing if that's above a certain photon emission threshold, our photon emission threshold will basically just be the speed of light, and if a nucleon tries to go past that, we'll calculate its excess velocity, convert that to energy, and then emit a photon with that energy. Okay, so I'm not really seeing any photons besides low energy red ones, and I want a variety, so I think I'm going to change how I'm calculating the color. Now we've got photons of all different types of colors being spawned all over the universe. I might tweak the specific values later, but for now I'm pretty happy with where it's at. Most of them are these low energy reddish photons, and some of them are the very high energy, like bluish, purplish, pinkish photons, and then you get kind of a mix of in between blue, greens, and yellows every once in a while. So now what I'm thinking we need to do is transfer the energy from the photons to the other particles when it collides with them. So basically we know that the particles have certain mass and velocity. The photons have a set velocity, but they also have an energy. So I think I'm going to do something kind of strange and not really too realistic. But let's say we take the energy of this photon and we give it basically like an energy vector that's in the direction of its velocity. And same thing for the photon. And then basically we just add the energy vectors together. So the particle's energy vector will be added together with the photon's energy vector to create a new one, and then we'll convert that energy vector into the particle's new velocity. So yeah, it's not really that realistic, but it'll allow me to change the velocity of the particle based on the energy that this photon has. So let's go do that right now. Okay, this is kind of weird. For some reason, after a certain amount of particles are spawning now, they're not reacting anymore. Yeah, I don't know what I did to this. Okay, I fixed that bug. It was mostly just me trying to change too much at once, which I do a lot. That's one of the #1 mistakes you can get caught up in, is just trying to change too much at once. So now here we've got the calculations for the particle's new energy vector. So now that we have this, we can just solve for its velocity. Back to our equation. So now if we want velocity, we just solve for that basically. So this is the new equation that we use to solve for the velocity, and what we're going to put in for the energy is just the magnitude of our energy vector. Okay, I'm actually not sure what's going on here. We might just have to ask the AI what exactly it wants. Oh, check this out. Here's the problem. So it does have to do with my use of vector 2. So the buffer, the GPU buffer, is expecting a vector 3 because of this here. So when it defines the buffer for the positions, it's allocating space for 3 floats. Whereas when I change it to vector 2, I didn't realize that I also had to change this as well. So this needs to allocate only 2 floats now. And same thing for this, and same thing for this. So now that should get rid of that error. Okay, that's really weird. Now the photons aren't moving. These guys are barely interacting? What is going on? Okay, let me change them back to vector 3 just to make sure. What'd I say about changing too much at once? I literally just did it right after I said that. Okay, that seems to be working. What we want to watch for are particles hitting a nucleon and causing it to move a little bit. So for example, if we take a look at this one here, it's moving, boom. And now you can kind of see it gets pushed out of it and to the other one. I'll try to find another example. So here it goes. It might hit this one, and it's barely moving right now. Boom, it collides. Oh my goodness, and it just shoots off in the other direction. So we might actually want to scale that down a bit. So what this mechanism does is it can kind of destabilize stable atoms. So this one right here is a pretty stable formation, but we have 2 photons coming for it. So it collides there. It's those 2 nucleons. And then they get sent flying because of the added energy. But I think I do want to tone it down a little bit so that they don't actually add that much energy. So this is at a 1/10 of the speed that it is normally. So here we can see like this one. Boom. It sends it flying in the other direction. And it went so far across the map that it came back basically to where it was to start with. But sometimes it also seems like the particles are allowed to travel faster than the speed of light when they're hit by one of these photons, so I wonder if that's another bug. Oh, you know what? I know why that is. It's because we need to clamp the velocity change here to the speed of light instead of just here, so that the velocities get clamped before they're assigned at the very end. Actually, no, we can't, because our position variable is being changed before the velocity is actually clamped. That's also why it's going super fast. Something interesting that does happen though, sometimes, is when a high energy photon hits a particle, and then that particle speeds up past the speed of light again, and then emits another lower energy photon, which may or may not be something that happens in real life. I think it might, maybe not, but I just thought it was interesting. Okay, I'd say that's looking pretty good. It's going pretty smooth. It might still look a little laggy due to recording, but when I'm not recording, it runs like butter when you forget it in the microwave and accidentally leave it for a whole minute. So there's actually one more thing I want to try before moving it to VR, and that is, notice when I spawn some protons and then some electrons here, the electrons don't really orbit. They tend to just kind of run into the protons and they both go flying, and they don't tend to stick around for very long. So what I'm wondering, instead of just having the electrostatic force be completely attractive all of the time, maybe at a certain distance we could turn it more into an orbital force instead of just an attractive force. So I've done a bit of coding off camera, and what I've done essentially in our compute shader is when we're iterating through particles and get to the electrostatic force, if the current particle is an electron and the other one is a proton, we're going to give some force to it in the orbital direction to try to make it spin clockwise, as well as giving it a little bit of distance from the protons by also adding a little bit of a repulsive force if they get too close. I did a bit of experimentation with that, and I've also turned off the photons for now just to see the effects of this a little bit more clearly. So now if we spawn in a proton and an electron next to it, it'll automatically start orbiting. Because the behavior of the electrons is not so chaotic anymore, it can now actually facilitate some of the behaviors that we see in real life. So in real life, electrons will help 2 atoms bond together, and so by fine-tuning the parameters a little bit, I've kind of got it to perform something a little bit similar. So now if we spawn another proton here, rather than being repelled by the other proton, it gets attracted just enough by the other electron so that that electron starts orbiting both of them. And we also have 2 protons here, so it can sustain 2 electrons orbiting it pretty easily. But if we add a third one, it can still sustain the orbit, so not quite like real life in that scenario, but the more electrons you add, the harder it is to sustain orbits for all of them. So let's add a 4th one as well. And now you can see because of that, one of them eventually got kicked off and thrown away. So this shape naturally supports 3 electrons orbiting. If we add a 3rd proton, now they will start orbiting all of them and kind of bond all of them together. And if we add a 4th electron now it does kind of orbit them a bit, but still kind of gets kicked out. It's kind of orbiting in the distance a little. Now let's add the neutrons back into the mix to kind of help stabilize things. So if we add one in the center here, these 2 will form a sort of a small atom, and it'll also attract another proton. It's not quite enough to attract that 3rd proton into the same atom, but now we have 2 atoms and they're both being bonded by these 3 electrons. If we add another neutron, now that should be enough attraction to pull in the 3rd proton and stabilize stabilize it into one atom. And it's still stable, holding a 3-electron orbit. Sometimes though you still get ejections, and one of the particles will fly away on its own. So let's add the photons back and spawn in a bunch of particles and just see how it performs now. So with everything all together so far, it is looking kind of chaotic, mostly in the middle because of all the mass. The gravitational force tends to clump everything together and smash the atoms together so that they all tend to kind of explode and split apart multiple times per second, while a bunch of the electrons sort of orbit together inside here. The electrons that don't fit tend to just orbit around the rim of the universe, spinning outside because they can't find an opportunity to get in. So I'm liking how this is turning out, but there's one more thing that I do want to add before we take it into VR. I don't feel powerful enough as the god of this universe. So what I want to do is, when I hold down certain keys, I want to be able to cause a powerful force to be emitted from my mouse cursor, either gravity, strong force, or electrostatic force, that will also influence the movement of the particles so that I can have a little more control over it. I think maybe for now I'll just add the gravitational and electrostatic forces. So for this I've defined some bools for whether or not the god ability is activated or not. And I'm also going to need to define some floats. God mass for gravity equals your mom.mass and a God charge, but also we want a positive version of this and a negative version. Okay, so now we've got a function for a God gravity ability so that when the God gravity is activated, we will add the acceleration return to the velocity of the current particle. Okay, and that should allow us to press the 1 key and then calculate velocity to add to the current particle's velocity so that it gets attracted to the mouse cursor. So the protons and the neutrons mass is 100. Let's set ours to 5,000. Now when I press 1, the particles will be attracted to my cursor gravitationally, but I don't know that it's strong enough. Let's try making it stronger. Let's set this to 10,000, or better yet, 100,000. Okay, let's add the same ability now, but for the electrostatic force. Okay, so there's a new function for the electrostatic ability, and now it'll also be added if the particle type is a proton or electron, but not a photon or a neutron. So now let's spawn in a bunch of particles. So we have gravity, and now if we press 2, oh, there we go. So now we've attracted all the electrons and pushed away all the protons. And now if we press 3, now we attract all the protons and push away the electrons. And if we press 1 and 2 at the same time, then we attract neutrons and electrons and push away protons. And if we push 1 and 3 at the same time, then we do the opposite. And if we push all of them at the same time, okay, well with that, I think it's ready to be ported into VR. So I'm going to have AI guide me through that and start a new project. Okay, I've got a new VR template project up and running. So we'll see what it's got for us right off the bat. It has this little 3D scene already set up. We're already getting some errors. Okay, looks like I just needed to install some Oculus extensions here. Wow, so many random interrupts for Unity to just update random stuff that I don't need. Okay, looks like it's still not detecting the device even though it's plugged in. Pretty frustrating. Here we go. You can't see this, but I just enabled developer mode on the Quest. Maybe that'll do it. Okay, so here we are in the VR Unity template, and I have spent the last several hours just trying to get this thing working, and finally it's here. So we've got our rig with our controllers. Right now we're just doing snap turns. I want to change that to continuous turning. So it's just got some example buttons and sliders and stuff that you can click. And currently I'm using the Air Link to stream what Unity is running to the Quest. I also tried using the physical link cable as well, and I didn't notice any difference in lag with the recordings. So hopefully it doesn't look too laggy as I'm recording it now. But now we're going to get rid of pretty much all of these objects and set up our own code and port everything in. Okay, here we go. Now we can move around continuously and turn smoothly. Now let's just go ahead and delete these objects and start putting in our own things. Okay, so here we are. I've finally ported it to VR, and there were just so many problems. I've been debugging all day, but finally fixed them all, and I added this skybox with the stars, and now we can kind of move around, spawn in some protons, and then I can press one of the buttons on top of this controller to switch to spawning neutrons with the trigger instead. Just like that. And then with the other controller, if we press the trigger, we'll spawn some electrons. And we can fly around and kind of pan like this and take a look at the little universe. And now you can get up close and kind of see in 3D the little atoms that they're forming, which I think looks super cool. Especially with the trails they've got in the electrons too. And then the photons just kind of look like a bunch of spikes or a big internet web just flying around. And you just kind of watch them do their thing and simulate. And now in order to do the abilities, if you press the grip on the left trigger, it'll activate the electrostatic ability, the positive version, and then if you press a button on top of the controller, you can switch to the negative version of it. You're going to track all the protons like that. And then the grip on the right controller activates gravity. And it kind of just clumps everything together in this big atom. Okay, you can let it go and watch it explode. So with that addition, that's pretty much all I wanted to add to this simulation. So I might come back to add stuff to it later. But for now, I think it's pretty good. It's about how I imagined it would be. So if you like this build, you'll love the video where I created and published a 2D pixel art game to Google Play. So go ahead and check that one out, and I'll see you there.